right, so like I said, I'm going to record this for people who haven't joined us yet or people later on, but this is the lesson 3, standard to metric conversions. We already did our bell ringer. You should have your attendance form filled in, and then you can watch this video on your own sometime if you need another way to look at it, but we're going to jump right into the practice so that we can have extra time to do the CK12 as we move along. All right, so when you open this practice here, you will have it right here, and let's go ahead and go through this together. So the factor label method is, we can read it, but it's a good way to do conversions. Okay, so let's look at the example that they have here in the practice. It says, how can the rate 4 quarters per dollar be written as a mathematical expression? This is important because this is where you're going to find your conversions. Okay, this is one way that you could find conversions. The answer, 4 quarters per dollar, is 4 quarters over $1. So we're making a ratio. It looks like a fraction. All right, so let's go ahead and look at this exercise 1 together. And I'll pull up the camera and show you what I'm doing with in my notebook, because we want to make sure that our notebook is useful for when we do have a quiz. Okay, so we'll start here. I'm going to title this page Factor Label Method. Okay, and we're going to go ahead and write, I'm going to make a note that Factor Label Method uses ratios as conversions. Okay, they look like fractions, and that's kind of important because, well, some of us were super good at fractions and some of us never want to see a fraction again. So we want to be mindful that we got to pull that stuff back out of our head. Okay, and so that's really important. All right, so let's look at this first exercise. We're making these ratios. It says change these phrases into mathematical expressions, just like a fraction. Include these in your answer. So making conversions is what I'm going to put in my notes. The first one, 12 eggs per dozen. I'm going to go ahead and write it down. That way I can see it when I'm given a quiz later. What does that look like when we make a conversion out of it? We just 12 eggs, because eggs are our unit, per 1 dozen. Right? And then let's look at B. 16 ounces per pound. So 16 ounces per pound. Notice there's no 1 on the pound, but when we just say pound, we know that it's a pound. Okay. And so that would look like 16 ounces over 1 pound. All right. We're like 55 miles per hour. Thank you. So this is one that we probably see pretty often, especially now that a lot of you guys are starting to drive. 55 miles per hour. That looks like 55 miles per 1 hour. And that means like I can drive, in 1 hour I can drive 55 miles. But am I always going to drive for an entire hour when I'm going 55? No. I'm not always going to drive 55 miles. It's just the rate at which I'm going. So that's an important thing when we're thinking about these conversions too. All right, I'd like for you to go ahead and do D on your own. Okay, go ahead and do D on your own and see what that looks like. So what you should have at 4D, hopefully you already had time to do that, 100 sheets per ream. So you would just have 500 sheets. Notice I keep my unit 1 ream. It's like that paper you have to buy for their printer, 500 sheets per ream usually. All right, let's continue. We're going to kind of skip this section, change these mathematical expressions into word phrases, because I feel like we can just do that verbally. 60 minutes per hour. Okay, so what does that mean when I say 60 minutes per hour? There are 60 minutes in 1 hour, right? 5,280 feet per mile. What does that mean? There, that's how many feet are in a mile. So if I said if I gave you a number of feet and said how many miles is this, you could use this conversion to figure that out. So we'll kind of skip on to the next part. Mathematical expressions like the previous examples are often called conversion factors. Okay. This is a very important term for what we're doing, conversion factors. So let's go ahead and label them. Okay, so all of these things are called conversion factors. And we're going to use those in the math that we do. Okay. All right. Now, some of these you're going to know, like 60 seconds in a minute. You guys all know that. You guys all know there's 60 minutes in an hour, those kinds of things. You guys probably all know there's 12 inches in a foot. And those are all things that you'll have to use as we go along. Okay, so let's go ahead and look at the example that they gave you, and then we'll do some examples in our notebook. Example, how many inches are there in 4 feet? All right, now in your head, you probably think, well, I just multiply 4 times 12, right? You're pretty smart people. You know how to do that. But what you're really doing when you multiply 4 times 12, you might not know this, but you're doing this conversion factor in your head. Yes, you are multiplying 4 times 12, and you're going to come up with 48. But that unit of feet has to go somewhere. Something has to happen. Otherwise, you would have feet inches. You know how when you do area, you don't have inches anymore. You have inches squared, or volume, you'd have inches cubed. But in this case, that unit has to go somewhere. And so that's why it's important to know how to use a conversion factor for this kind of math. So we're going to skip the example. You can look at it a little bit more carefully if you want to later on, and we're going to go ahead down and do some actual examples here. Okay, so let's look at A here. How many seconds are there in 10 minutes? Well, you guys can probably do that one in your head, but I want you to think about the why do you do it that way. Okay, so if I have how many seconds are there in 10 minutes, I'm going to start with 10 minutes. I'm going to write down my problem. And what I want to find out are how many seconds. So I think to myself, all right, what is my conversion factor that I'm going to use? I know that 1 minute equals 60 seconds. But I could also write that in the conversion factor that we said, 60 seconds per 1 minute is also true. So I'm going to use this conversion factor right here to set up my problem. Now, I know, I get it. You guys are like, just multiply it. I know. But keep that in your head, because when they get a little bit harder, then you're going to be able to use what you already know, because you are smart and you know how to do stuff. We just have to show what we're doing with the units. Okay. So when I look at my conversion factor, I have minutes is what I'm starting with. So whatever I start with has to go on the bottom of my conversion factor. Okay, so just like you guys said, just multiply it. All right, so 10 times 60 is 600, right? Yes, because you go to 2 zeros. But my minutes cancels out because I have one on the top, one on the bottom, so I get rid of them. I am saying minutes divided by minutes gives me 1, and when I multiply by 1, I get my 600 seconds. Okay. Because let's go on to the next example and we'll go a little bit more in depth, but the units are what you're trying to fuss with these factor label problems. Okay, as we get to higher, bigger and better math, that's going to be critical. Okay, so let's look at B. How many minutes are there in 141 seconds? So they flip it on us. We have 141 seconds. Now, somebody said, what'd you say, Chris? Okay, and how did you do that? How did you do that? All right. Now let's look at what that looks like, because you could do that right in your head. We're going to use the same conversion factor. And I know what you're thinking. If I can do it in my head, why do I have to do it on paper? Because you have to show your work. You've been told that since you were in like whatever grade. So we start with what we have. So we just rewrite 141 seconds. All right, that's what we have. We're going to have to use this conversion factor. But remember what we set up here? Whatever I start with has to go on the bottom. So I have to put seconds on the bottom. And in this conversion factor, 60 goes with seconds. So 60 on the bottom, 1 minute on the top. So when I'm doing this, just like we did up here, you guys said just multiply it. You're going to multiply, but you multiply straight across. And so you get 141 times 1, which is 141. But look at the units. You get second minutes. That's not a thing, is it? Second minutes? No. So then you multiply straight across the bottom. You get 60 seconds because there's nothing to multiply by. And we can see that that seconds is going to cancel because seconds divided by seconds gives me 1, which is multiply 1 by anything and it's just itself. So then if I do my math, I'm going to type it into a calculator to get a very specific number. Okay, so we're just typing 141 divided by 60 is just like Chris said, 2 minutes and some. So it's 2.35 minutes because my seconds canceled out and my minutes are what's left. Right? So you already knew that you had to divide, but what you're really doing in your head, you're multiplying by 1 and then dividing. All right. Give me a thumbs up if that kind of makes sense. Okay. All right. So let's go on and do a couple more examples, and then I'll let you work on your own. And so C is a pretty good example of an abstract sort of thing. If you look at C, C says how many donuts are there in 7.8 dozen donuts? Well, just like we did up here, I'm going to write down what I have. 7.80, which is a weird number when we're thinking about donuts. Dozen. But I want to know how many actual donuts there are. So what conversion factor am I going to use? How many are in a dozen? How many donuts are in 1 dozen? 12. So 12 donuts. Notice donuts becomes my unit in this. Is 1 dozen. Or 12 donuts per 1 dozen. So the same process. 7.80 dozen times, I'm multiplying by that conversion factor, whatever I start with has to be on the bottom. Then I'm just going to now I have to keep my conversion factor together. So then I can see I'm going to go 12 times 7.80. That gives me 93.6. Now look, dozen donuts. That one kind of makes sense when you look at it, but we go straight across the bottom. We have just one. And our dozen, that unit, is going to cancel. So we're left with donuts. So we're going to have 93.6 donuts. That's a lot of donuts. All right. Now they're not. And this one is just the opposite. So if I look at D, how many dozen donuts are there in 46.2 donuts? Am I going to multiply by 12 or divide by 12? I got a couple people say divide and a couple people not say anything. Kidding. All right, so yeah, you're gonna divide because this conversion factor is gonna be upside down. So let's check that out. Okay, and then I'll kind of let you go on your own for a little bit. So D says 46.2 donuts. And we're going to use that same, or equals how many dozen. So we're going to use that same conversion factor, 12 donuts in 1 dozen. So if I start with what I have, 46.2, donuts is a long word to write, just saying. 46.2 donuts times, okay, wait. I have donuts is what I start with. So my donuts now needs to be on the bottom. 12 donuts. So when I multiply straight across, I get 46.2 for my number, because 46.2 times 1 is 1. And I multiply straight across the bottom, I get 12. So I'm going to have to divide. Now, some of you said right off the top of your head you had to divide by 12. Some of you weren't really sure. So when you use the factor label method, it sets it all up so that you know for sure what you do. So 46.2, we see that our donuts cancels because we have a donut on top and a donut on the bottom. We're left with dozen, and that's going to be our unit. So when I go to do my math, I'm going to go 46.2 divided by 12 is 3.85. So that's my answer. All right. Now, if you go to the donut store and say, I want 3.85 donuts, they're going to be like, no. So you'd have to order 4 dozen donuts. And you guys do that when you are planning a party or you're trying to figure out how to feed people. You do this kind of math in your head. But to write it down on paper is A, scientific, and B, shows your work. You guys have heard show your work, show your work, show your work probably all of your school life. This is the way to show your work for that. All right, so let's check out what's left in the practice page here. These ones are pretty straightforward, E and F, so you'll do those on your own. But I do want to do G because it has a rate in it that I kind of just want to show you the example for. All right, let's bring that back, and we'll do G, and then you guys will be responsible for the other practice problems. So G says if you're going 70 miles per hour. Now look at this, 70 miles. It shows it like this, in the work, but you want to remember that it's 70 miles per 1 hour. That same idea of a conversion factor. How many miles do you travel in 0.681 hours? 0.681 hours. Now, when I look at that, it's hard to tell what it's really asking. So you got to go back to the question and say, okay, where's the question here? It says, how many miles? So I'm going to set that up. I'm going to say equals miles. This is the number I'm given. Here's my conversion factor. And this is what I'm trying to find. So always going back to that question and finding what is it asking me is how you're going to figure out what your conversion factor is, what conversion factor is needed. So we start with what we're given. In this case, it is 0.681 hours. Multiply by our conversion factor. So it's already set up correctly where we need the hours on the bottom. So what math operation do I need to do right now? I'm going to multiply straight across the top and multiply straight across the bottom. When I do that, my hours cancel. So I'm going to pull in my calculator here. We're going to go 0.681 times 70 is 47.67 miles. When I go straight across the bottom, I had just 1 hour. So 47.67 divided by 1 is itself. So my answer is 47.67 miles. All right, so sometimes they give you the conversion factor in a rate in the question. All right.